All right, so the first topic for today is number facts. We are going to learn some interesting tricks which will help us to add and subtract numbers. And what we're gonna do is we're gonna use number line for subtraction today. Let's say we have an example like this. Let's say we have to do 100 minus 76. What's going to be an answer? We can do this the standard way. We can go 100 minus 76 and we do the column thing. But the thing here is that a lot of people, they make mistakes at this, and a lot of people, they don't like this kind of subtraction. So I have another interesting method for you. We can transform this a little bit. We can make this into something like this: 76 plus something is equal to 100. And as you can see, this something and this something is in fact the same thing altogether. Right? So we have to find it. How do we find it? We draw a number line. We have to use a number line for this, and then we go 70, 80, 90, we get to 100. So we have to find 76 on this number line. 76 is probably going to be around here, between 70 and 80. So we go 76. First we make a small step to 80. 76 to 80. We have to add 4 to get there. But our ultimate destination is 100, of course. We want to get to 100. So we jump from 80 to 100. We have to add 20 here. Together, 4 and 20 give us 24, which is our answer. 76 plus 24 equals to 100. And respectively, 100 minus 76 is equal to 24. Let's do a couple more examples on this topic. Let's do a couple more of them. Let's say we want to do 39 plus something is equal to 100. What is this something? Yeah, so again, we draw a number line. We go out there and we draw a number line. And we can make it a little bit easier actually. So we can go 30, and then we have our 40. Somewhere here is our 39 where we're going to start. And we don't have to draw all of these numbers actually. We don't need them. So we can only draw 100 somewhere here. We can only mark 100. And the way we go is we go from 39 to 40 first. That is plus 1. And then we go to 100. That's going to give us plus 60. So plus 1 and plus 60 together is 61, which is our answer. All right, so this is the method. Let's try one more subtraction thing. Let's try one more with subtraction. So let's say we actually want to subtract. 48 from a 93. This one's going to be a little bit harder. So we transform it, right? 48 plus something is equal to 93. Okay, let's do it. We draw a number line, of course. And then we start with 48. So we can kind of do 40 here. Then we do 50. Somewhere here is our 48. And then we get to 93. 93 is our final destination. So again, we started 48. We get plus 2. And So 48 to 50, we have to add 2. 48 plus 2 equals 50. And then from 50 to 93, pay attention here, we have to add 43. So we go plus 43. Plus 2 and plus 43 together give us 45, which is going to be our answer. All right, let's do the last example. Let's do something harder than that. We can do, you know what we can do? We can even subtract numbers up to 1,000 by using this method. Even numbers up to 10,000, up to 100,000, if you're really good at this, you can do that. So let's do an example 4. Let's say I want to do 1,000 minus 544 equals to, we don't know, right? So we subtract it. Let's transform it. Okay, I'm gonna make a big square so that we can see my answer perfectly. So of course we transform it. So 544 plus 1,000 is equal to, we don't know what, yeah? Number line, of course. If we do the number line, here we can actually start from 544. It's not a big deal. 544. So the next thing to 544, the next thing is probably 600. Gonna draw it here. And then somewhere in the end, our final destination is 1,000, yeah? Okay, so here we have a small problem, right? It's 544 to 600. It's not that easy to find. So you know what we can do? We can break it into even smaller steps. We can go first from 544. We can first go to 550. And that is plus 6. Then we can go to 600. It's going to be plus 50. And we make a big jump all the way to 1,000, which is plus 400. Together we have plus 6, plus 50, and plus 400. Together they give us 456. Another review topic for today is adding and subtracting numbers. First, we're going to do the addition. Let's say we have 743 plus 89. Please notice that we write units under units, tens under tens, and hundreds under hundreds. We have only 100, so we don't have to write anything here. We have 700. So we go 3 plus 9, which is 12. We write 2, we keep 1. 4 plus 8, again, is 12. And then we have one more, which is makes it 13. And we keep 1. 7 plus nothing is 7, and then plus 1 is 8. So we get 832. Let's say we do a subtraction. 811 minus 179. Again, we start from the right, we start from here, and then we go like this. 1 minus 9, we have to borrow 1. We have to borrow 1 from here. So 11 minus 9 is 2. Then we have to borrow something from here because we can't subtract anything from 0. So 10 minus 7 is 3. And we have 7 minus 1, which is 6. So the answer is 632. Okay, this is addition and subtraction. I'm pretty sure you all are familiar with this by now, but again, just a small review. It doesn't hurt. Okay, and this is a small word problem that we will be doing. 18 years ago, Chris was 5 years old. How old will he be in 16 years' time? So a good way to solve a word problem is to make a small picture or maybe a diagram. Whatever helps you to visualize it. So let's do kind of a age line. We will draw like an age history of Chris. So here, this is a Chris's age now, right? It's here. This is kind of in the middle, I would say. Let's do it like this. Chris's age now is here, and we don't know what is it. So we know that 18 years ago, Chris was 5 years old, right? So if we go 18 years ago back, if we go 18 years back in time, we will get 5. So this is if we do minus 18, right? So we can actually find what is his age here, right? If we do 5 plus 18, we would get an answer which is 23. And this is his age right now. How old will he be in 16 years time? So we have to go from the present age. So right now we figured out he's 23, and now we have to go in the future. We have to jump in the future in 16 years time. 16 years time. Right? So we go from 23, we go plus 16. 23 plus 16 is equal to 39. And this is an answer to this question. Okay, that's it about addition and subtraction. Real short, real easy topic. Another topic for today is multiplication and associated division facts. So here we have a multiplication table of numbers from 1 to 10. Again, I'm pretty sure most of you are familiar with this topic, but again, this is just a recall, and I hope I will make it easier for you to use the multiplication. This is a very big table with a lot of numbers, and it's a bit hard to remember them all. That's why we have some facts that help us to make it shorter. So the first thing is that order doesn't matter. Order does not matter. So what does that mean? It means if we do 7 times 8, it's the same thing as 8 times 7, right? So order does not matter. Another thing is multiplying by 1 does not change the number. That means that if we do 4 times 1, it's still 4. So number is not changing. And what else? If we multiply by 2, it's the same as doubling. Another fact, which makes it really easy if you think about it. We don't even have to think about this anymore. And one more thing for today is if you multiply by 10, it's just, you just have to add this 0 to the number. Let's say it like this. To multiply by 10, you just have to add 0 to the number. I can give you an example of this. Let's move it a little bit. It's too close. Yeah, like this. To multiply by 10, you just have to add 0 to numbers. So for example, 8 times 10 is 80, right? So we just add the 0 to the end. Some real easy stuff. But that helps us to reduce this table. We can make it a lot smaller, actually. So all the numbers we have now that we excluded all the others, let's think about it. So 10, we don't have to remember this because we have this fact, right? We don't have to remember multiplication by 1. We don't have to remember multiplication by 2. And also, like half the numbers are the same because of order. Order doesn't matter, so that makes it this table. Now it's way smaller. And what you have to remember is also not so much anymore. But wait for it, there is more facts that will make it easy for you. So another fact is we can make 4 easier. 4 is made easy. So to make 4s easy, you just have to double the number and then double it again. That's 4s for you. Another thing is 5s. 5s are also pretty easy to find. Yeah. Not the most convenient thing to write on. 5s made easy. So to multiply a number by 5, we just have to multiply it by 10, and then we can halve it. And for this one, I'll give you an example. We can do, for example, if you want to do 8 times 5, it's the same as 8 times 10, which is 80, and then divided by 2, which is 40. So we don't have to remember anything about 5. And one more thing is 9s made easy. We can also make 9s really easy to remember. And for this, I have a small picture for you. So 9s made easy. What you can do to multiply by 9 is, for example, if you do 9 times 4, you take both of your hands out and you bend the 4th finger from left to the right. Yeah, you bend the 4th finger, and then you have an answer right on your hands. You have 3 here and you have 6 here, which makes it 36. So all these facts, we have order doesn't matter, multiplying by 1 doesn't change the number, multiplying by 2 is doubling, multiplying by 10 is just adding 0, 4's made easy, 5's made easy, 9's made easy. We can actually make it even smaller, this table. So we can make it really small, like this. And that's the final form. This is all the numbers that you actually have to remember with multiplying. The next topic for today is decimals, and I have a couple of exercises that I will solve to show you how it works. So first one is about showing the numbers on the number line. We have 0.3. First we have 0.3, and 0.3 we have 0 and then 0.5, so 0.3 is obviously between them. And we can just count those things, right? We go 1, 2, 3, 4, 5. So this is going to be 0.1, 0.2, and here we have our 0.3. 1.3 is around here, yeah? So we can already, if you want to, you can kind of number all of them. So this is 0.1, 0.2, 0.3, but I think this is fairly obvious in this case. This is not a very challenging number line. So 0.3 is going to be between 1 and 1.5 in here. And here we go, 0.1, 0.2, 1.1, 1.2, and finally we have 1.3. In the same manner, 1.9, pretty close to 2. Here we go, 1.6, 1.7, 1.8. We finally get to 1.9. And this next exercise is kind of an opposite of what we just did. Here we have to write as decimals the letters marked on the number line. So we already have a letter on the number line, and we have to say what kind of number this letter refers to. So first we go A. A is, as you can see, A is right in the middle between 0 and 1. So it's probably going to be, and we can count them. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that this is tens, right? We have a number line with tens on it. And A is right in the middle, so again 1, 2, 3, 4, 5. A is going to be 0.5. B, closer to 1, 5, 6, 7. B is 0.7. And C is right next to 1, so we go 1, and then we have 1.1. We have 1.1. D is a little bit more far, so we go 1.1, 1.2, 1.3, 1.4, 1.5. We can kind of mark these for convenience. We go 1.6, 1.7, 1.8. So D is equal to 1.8. Okay, next one is a bit more challenging. I'm going to make it bigger. Write down the positions of each of the letters on this number line. Okay, so we're gonna start with A again. So here we have, this is not a decimals, this is not a tens, this is a thousands actually. Or no, sorry, this is hundreds. So we have 0.1, 0.2 in here, you see, 0.1, 0.2, 0.3, 0.4. And so what happens is we have to divide 0.1 into 10 parts. So what do we have? Here we have 0, again, so it's 10, right? We can count it just to check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what happens if we have to get from 0 to 0.1 in 10 steps? We can start by saying that this is 0.01, 0.01, this is 0.02, 0.03, and finally we get to H, but wait, this is not what we need right now, 0.04, 0.05, 0.07, 0.09, and A is really easy. Actually, we already have a title for A. A is 0.1. This one's really easy to find. B is right in the middle. It's right in the middle between 0.2 and 0.3. So we start with 0.2. We go. This is 0.21. This is 0.22. This is 0.23. 0.24, and finally we get to B, which is 0.25. C is right in the middle. Okay, we can actually write it here. So A is 0.1, B is 0.25. C is right in the middle between 0.4 and 0.5, just like B was in the middle between 0.2 and 0.3. So by analogy with B, we can say that C is 0.45. E, not really in the middle. There's a D somewhere missing. Okay, we're gonna go by alphabet order. So we go A, but actually, why do we have to do this? Let's just do all of them like this. H. Let's do H. 1, 2, 3, 4. So 0.01. We already concluded that H is 0.04. So 0.04, 0.1, 0.25, 0.45. E is going to be, so we go 0.5, 0.51, 52, 53, 54, 55. Finally, we get to 56. E is 0.56. F, 0.61, 62, 63, 64. F is 0.64. D is, we can start from here, 0.75 because it's in the middle. So we go 76, 77, 78, 79. D is 0.79. And finally G is 91, 92, 93, 94. G is 0.94. And this is all of it. Okay, another one we have is, now we have to do a kind of an opposite assignment again. Okay, I'm going to erase this. Copy this number line. On your number line, show the points. A is 0.2. So 0.2, we already see that it's right here. This is our A, 0.2. B is 0.25. So again, as I told you, if there is 5, it's right in the middle between 2 and 3. And you can see it like this: 0.21, 0.22, 23, 24, 25. So B is 0.25. C is 0.45, right in the middle between 4 and 5. So we go, this is C. D is 0.40. 0.40 is the same as 0.4. So we can mark it here. This is our D. 0.30 is the same as 0.3, which is here. This is our E, and F is 0.05. So we can go like this. We go 0, and this is 0.1. So we go 0.01, 0.02, 0.03, 0.04, 0.05. So this is our F. F is here. All right, decimals and place value. Here we have a small picture which explains us how the place value works. So we have different letters here for this number. Number 384.615. And so what happens here is we start with hundreds. We have 3. You can kind of see it from the way I say it. In English, it's pretty self-explanatory for most part. So 300. So we go 3 is the hundreds, right? So this is our hundreds. Uh, 80. So 80 is tens. And U is for units. So 384. U is units. And then after point, we have the decimal part, which sounds pretty familiar, but please remember it's not the same thing. So we have, let me try to make it nice. So here we have, this is what we call tenths. Sounds very similar to tens, but please don't confuse them. This is what we call hundredths. It's like a 1/100th of something. So again, not the same as hundred. It's a different thing. Oh, sorry. I have a typo there. And here finally we have thousands. So to reinforce, to remember this better, I prepared a couple of exercises. Okay, here we have to give the value of each underlined digit. Let's start with A. In A, okay, so we can see that this is units, and this is going to be our tens, right? So in A we have tens. In B we have, so yeah, you can just so what helps, you can draw a table if it helps you to solve this. I will draw a small table for B. So we have this kind of like a table with three numbers. We have 6, 2, and then point, and then we have 4, 62.4. So we start with tens, then we get to units, and then there is tenths, right? Not the same as tens. 1/10, like this. So what we have here is we have 2, which is of course units, right? So in B we have units. In C, so here is our tens, here is our units. This is 1/10, tenths, right? And then we have hundredths here. Pretty similar word to hundreds, but try not to confuse them. In D, so we go 1/10, 100th, and then finally we get to thousandths, right? It's this kind of thing. So D we have thousandths. In E, 1/10, this is a hundredths, right? And then finally this is again thousandths. F we have tenths, right? Right after the decimal point we have tenths. And finally G, we have, this is tenths, and this is our hundredths. I'm going to, sometimes you can write it like this, like 1/100 part, thousandths if 1/1000, 1/1000 in here, and then tenths, it's 1/10, hundredths, it's 1/100, like this. Okay, a couple more exercises. Here we have to arrange the numbers in order of size. Smallest first. You have to write the smallest numbers first. So what do? We do A. We have, look at these numbers. We have 12.5, we have 14, 6.35, 10.2, 8.323, and 0. So first, let's look at the whole part. We have, so the whole part is the part which is before the point. So 12, 14, 6, 10, 8, and 0. So here obviously the smallest one is 0. We can start with that. Actually, the first example is very easy because each one of them has a different whole part. So we don't even have to look at the decimal part of it because the whole part is already different for each of them. So we go 0.099. It's definitely the smallest. Then we go 6.35, 8.323, 10.2, 12.5, and finally we have 14. So what you can do is you can check yourself. And before I start doing this, you can pause the video and you can try to do it by yourself. And then you can check the result when I'm finished with it. Okay, I hope you gave it a try. And now let's do it together. So here, this becomes a bit tricky, right? We have 2, 2, 2, 2, and everything is 2. Everywhere the whole part is 2, so that does not help us. It does not help us at all, I would say. So we have to look at the decimal part here. And of course, we start with tenths. We start with the biggest decimal part, which is tenths. So we have 4, 5, 5, 4, 4, 4. So 5 is obviously going to be on the larger side. So if we look at the ones with 4, right? Let's look at them first. I'm going to circle them. The smallest one here is the one which has only 4, 2.4, because in case of decimals, you can add zeros indefinitely, they will not change anything. 2.4 is the smallest number here. 2.4. So let's erase it. It's out of equation. Okay, then we have to, there is a bit of a challenge, as you can see. 2.412, 2.410. So a small trick here, a small trick which you can use is, if it's a decimal part, you can add zeros to it. You can add zeros to it like this. Like if you have 2.41, you can make it 2.410000 indefinitely. It's not going to change anything because this is how decimals work. 2.41 and 2.412. They are the ones who are right now competing, because 2.44 is a bit larger than those two, right? So 2.41 and 2.42. Let's take a look at them. 2.41, again, we can just add the 0. We get 2.410 and 2.412. Well, then 2.412 is obviously the larger number, right? So next one in the list is 2.41. Then we have 2.412. Then we have our last thing, which has 0.4, which is 2.44. We can write it here. And then we get to 5s, right? 2.5 and 2.501. So again, as I told you, the one which has only 5 is the smallest thing, which can be with 5. And then we go to 2.501. It's a little bit larger. And we have C. This one's really confusing. Again, you can pause the video and you can try it yourself. I hope you did. Let's go on. Let's try this together. So we have 0.4, 0.04, 0.44, and they look so similar. This is so confusing, right? They all have 0. They all have 0 in them, so the whole part does not help us at all. And so what we have to look next at is the tenths, right? Next we have to look at the tenths. So if we look at the tenths, we have 0.4, so 4, and the rest of them, and this one has 4 also, so they are on the bigger side. They are on the bigger side, definitely. So for now we're gonna exclude them. We want to find the absolute smallest number first. So for now we exclude them. So we have the candidates for the smallest number is 0.04 and 0.044. And as I told you before, you have to look at the number which has the least digits in it, because we can make it 0.40. And 40 is obviously less than 44. So we write 0.04 is our smallest number. And next one is 0.044. Okay, now we can look at the bigger ones. Now we can look at the bigger ones. The first one is, of course, the one which has the least digits in it, because again, as I told, they all have 4 in them. All these numbers, 0.4, 0.44, they all have 4, it's this one, right? They all have 4 tens in them. So first we have to choose the one which has the least amount of digits in it, which is 0.4. Okay, so our contestants are, the remaining numbers are 0.44, 0.444, and 0.404. So they almost look the same, except that something is missing here, right? Something is missing here. Well, we can help that. We can add a 0 in the end. So we get 0.440. And now it becomes easier to compare them. 440, 444, 404. Pretty similar. So we go, of course, 404 is the next one. Then we have 440. Actually, it's 44, right? Actually, it's 44. And then we finally get to 0.444, which is the biggest number on this list.